RLHF and constitutional AI. How models learn to behave. Here is the raw model problem. When a language model finishes pre-training, it has absorbed encyclopedic knowledge but has zero judgment. Ask it how to treat a headache and it might autocomplete a medical article, a Reddit thread about drug abuse, or a medieval remedy involving leeches. It treats all of these as equally valid continuations. It will generate hate speech, fabricate citations, and leak personal data from its training set. Not because it's malicious, but because those patterns exist in the data and it has no mechanism to prefer one pattern over another. This is the alignment gap, the distance between a model that can generate helpful text and a model that will generate helpful text. Everything in this video exists to close that gap. So how did we get from that chaotic raw model to something like Claude or ChatGPT that actually feels aligned? The answer isn't one technique. It's an evolution of ideas. Here's what we'll cover. First, RLHF reinforcement learning from human feedback. This was the breakthrough that made ChatGPT possible. We'll break it down step by step. Then we'll see where RLHF breaks down. It's expensive, it's inconsistent, and models learn to game it. That sets up the real question: what if we didn't need thousands of human labors? What if we could write down a set of principles and have the model align itself? That's constitutional AI. And it changes everything. Let's start with RLHF. Reinforcement learning from human feedback. This was the technique that turned raw language models into the assistants we know today. OpenAI used it to build ChatGPT. Anthropic used it to build Claude. It was the first practical method for teaching a model what humans actually want. But before we can understand RLHF, we need to understand the pipeline it sits inside. The modern alignment pipeline has 3 stages, each building on the last. Stage 1, pre-training. This gives the model its knowledge and language ability. Billions of web pages, months of compute. This is the expensive foundation. The result? Enormous recall, but no compass for right or wrong. Stage 2, Supervised Fine-Tuning, or SFT. This teaches the model the format of being an assistant. Question in, answer out, be helpful. The result? It follows the script, but it is imitation, not true comprehension. Stage 3, reinforcement learning from human feedback. This is where the model learns values, what's good and what's harmful. Each stage is cheaper than the last, but adds the most important layer. The result? A model that can finally tell good from bad. Knowledge gives way to behavior, and behavior gives way to judgment. In supervised fine-tuning, humans write ideal question and answer pairs. Thousands of them. Explain quantum computing gets a clear, structured response. Write a poem about rain gets a creative, well-formed poem. The model trains on these demonstrations using standard next token prediction. Before SFT, you ask hi and the model autocompletes hi there I am a large language model trained on. After SFT, it responds hello, how can I help you today? It's learned the format. But here's the limitation. SFT is mimicry, not understanding. The model copies the style of good answers without knowing why they are good. It can't generalize to situations the training data didn't cover. For that, we need something deeper. The next step is building a taste engine. For each prompt, the model generates multiple responses. Human labelers rank them. Is it okay to jaywalk? Response A says yes, just cross. Response B gives a nuanced legal and safety analysis. Response C says sure, here's how to avoid getting caught. Humans rank these. B is better than A is better than C, a separate neural network. The reward model is trained on these rankings. It takes any response as input and outputs a single score between 0 and 1. After training on over 100,000 comparisons, its reward model can predict which response a human would prefer. It converts messy, subjective human preferences into a differentiable signal the language model can optimize against. Now comes the reinforcement learning loop. The language model generates a response. The reward model scores it. PPO, proximal policy optimization, nudges the model's weights toward high-scoring outputs. But there is a critical leash, the KL divergence penalty. This measures how far the model has drifted from the original SFT baseline. Too far and it gets penalized. Why? Without this constraint, the model learns to game the reward. It discovers that sounding extremely confident scores high, so it starts generating responses like "I'm absolutely certain Napoleon was born in 1821. Wrong, but confident. The KL penalty keeps the model grounded. It can improve, but it can't become a sycophantic caricature of helpfulness. This balancing act, maximize reward while staying close to the baseline, is the core engineering challenge of RLHF. RLHF works. InstructGPT proved that a 1.3 billion parameter model aligned with RLHF was preferred by humans over the raw 175 billion parameter GPT-3. But it has serious problems. Cost: OpenAI hired 40 full-time contractors just for labeling. At scale, annotation costs run into millions. Inconsistency: labelers agreed with each other only 73% of the time. There's no ground truth for subjective preferences. Reward hacking: without careful tuning, models exploit blind spots in the reward model, producing nonsensical text that scores high. And scalability: every new language, culture, or domain needs new labelers with new expertise. RLHF doesn't scale. So the question became, is there a way to align models without an army of human labelers? In December 2022, Anthropic proposed a radical idea. What if instead of asking thousands of humans to rank outputs, you wrote down the rules and let the model judge itself? They call it constitutional AI. The Constitution is a set of 16 explicit principles written in plain language. Choose the response that is most helpful. Choose the response that is least likely to cause harm. Choose the response that is most honest and accurate. These aren't vague guidelines. They're specific, auditable rules that the model evaluates against. Humans write the principles once. The AI applies them at scale. No labeler army. No subjective disagreement. Just principles. Here's how it works in practice. A user asks, "How do I pick a lock?" The model generates its initial response, detailed instructions for lock picking. Now the model reads its own response against a principle from the Constitution. Is this response likely to cause harm? It critiques itself. This provides detailed instructions that could enable the legal activity without asking about the user's context. Then it revises. Lock picking is a legitimate skill for a locksmith. If you're locked out, I'd recommend calling a certified locksmith. If you're learning the trade, here are reputable training resources. This critique revision loop runs multiple times, each pass sharpening the response against a different principle. The result is a response that's helpful but not harmful, informative but not dangerous. No human was in the loop. Just principles applied systematically. The critique revision loop handles the supervised phase. But constitutional AI goes further with RLHF, reinforcement learning from AI feedback. Instead of human labelers ranking responses, the AI itself evaluates which of two responses better satisfies the Constitution. These AI-generated preference labels train a reward model, just like in RLHF. Then reinforcement learning proceeds as before. Same pipeline, but the labeling step is fully automated. The numbers are dramatic. What took human teams weeks now takes hours. What cost millions costs pennies. And critically, AI labeling is consistent. It applies the same principles to every comparison, every time. No inter-annotator disagreement. No cultural bias. No fatigue. The result: models that are harmless but non-evasive. They explain their objections rather than simply refusing. Neither approach is perfect on its own. Constitutional AI is consistent and auditable. You can read the Constitution. You can change it. You can explain every decision. But it's rigid. Principles can't foresee every edge case. RLHF captures nuance. Humans into a cultural context and edge cases that are hard to write rules for. But it's expensive, inconsistent, and opaque. You can't read the rules because there are no rules, just aggregated preferences. The real answer? Modern models use both. Constitutional AI handles the 95%, the predictable cases where clear principles apply. Human feedback handles the 5%, the edge cases, the cultural nuance, the novel situations no one anticipated. It's a hybrid, and it's working. The evolution continues. In 2023, researchers discovered something surprising. The entire RLHF optimization problem, the reward model plus PPO loop, has a closed-form solution. You don't need a separate reward model. You don't need reinforcement learning at all. Direct preference optimization, or DPO, reparameterizes the problem so the language model can be optimized directly from preference pairs using a simple classification loss. Same result, radically simpler pipeline. The trend is clear. Less human labor, more explicit principles. Complex multi-stage pipelines giving way to simpler, more direct methods. Train time alignment expanded to inference time alignment, where models can be guided by principles in real time. The toolkit is getting sharper. Let's bring it all together. Pre-training gives a model knowledge. SFT teaches it behavior. And the final stage teaches it right from wrong. RLHF proved that models can learn human values. Constitutional AI proved they can learn principles instead of just mimicking preferences. DPO proved the pipeline can be radically simpler. The alignment problem isn't solved. Models still hallucinate, still get gamed, still struggle with edge cases. But the trajectory is unmistakable from brute force human labeling to principled self-improvement. Next time you talk to Claude, ChatGPT, or Gemini, this is the invisible machinery that makes it helpful instead of chaotic.